You have probably heard someone say something like, this result is statistically significant. P is less than 0.05. It sounds pretty official, right? But what does that number actually mean? The p-value is one of the most used and most misunderstood ideas in statistics. It's supposed to tell us how unusual our data would be if nothing interesting was actually going on. In other words, if the null hypothesis was true. But people often treat it like a stamp of approval saying, this result is real, and that's not really what it does. Here's the simple version. A p-value is the probability of obtaining results at least as extreme as the ones we observed, assuming there is no real effect or difference. That's the null hypothesis is true. A small value such as 0.02 means that there is only about 2% chance we would see results this extreme if there were no effect. That suggests that our data is unlikely to have happened by random chance, which gives us evidence to reject the null hypothesis. On the other hand, a large p-value such as 0.6 means our results could easily happen by chance. The data are consistent with the null hypothesis, so we don't reject it. In short, small p-value means unusual data under the null, and large p-value data that is fit fine with no effect. Now, here's what a p-value doesn't tell us. It doesn't tell us the chance that our result is true. It doesn't tell us how big or meaningful the effect is. And it definitely doesn't prove that our finding is important in the real world. A p-value is always between 0 and 1 because it's a probability, but it's a conditional probability. It tells us how likely the data are if the null hypothesis was true. It does not tell us how likely the null itself is true. And that's why good analysts never rely on p-values alone. They always look at sample size, effect size, confidence intervals to understand the full story. Even though it's confusing, p-value is still incredibly useful. It helps researchers, doctors, data scientists decide whether the result could just be random noise or might show a real effect. Think of a headline such as you see in the corner, drinking a glass of red wine prevents heart disease. That study might have found that P is less than 0.05 and called it significant. But does that actually mean that red wine prevents heart disease? Not necessarily. Maybe the study had a small sample size, or maybe wine drinkers were just healthier in other ways. The p-value alone cannot tell us that. It only says that data would be rare if there were no effect at all. Used correctly, p-values help us detect real patterns in data, but if used carelessly, they can lead to overhyped headlines and bad conclusions. So next time when you hear a result is statistically significant, remember, a p-value is not proof of truth. It's a measure of how surprising your data would be if there were no effect scenario. It is a useful tool for decision making, but it's only one piece of the puzzle. Good science means looking beyond the number to see whether the effect is meaningful, replicable, and real. That's why the p-value remains both powerful but often misunderstood.